Lesson 9.2 is first derivative from graph of f. Number 1 says, given the graph of the function f below, determine all intervals on the open interval -9 to 9 where f prime of x would be greater than or equal to 0 and f of x would be greater than or equal to 0. So this is just a normal f graph. This lesson is guided where you're going to be able to drag this yellow point, and all that does is gives you that slope at an instant. So you can kind of see as I move the ruler how the derivative would change. And so look, I'm getting flatter and flatter and flatter and flatter, becoming 0 as I get to the top of this. And then I would have decreasing tangent lines or negative slopes going down, 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 down. And then I would get to another 0 down here at the bottom. And then I would be coming back up. So it's kind of hard to do with my ruler, but it'll make more sense when you do it on Delta Math. But anyways, we're trying to figure out where the derivative, so I think that's slope, greater than or equal to 0 means slope has got to be positive. And then this is just simply our y's of this graph need to be positive. Okay, so where is slope positive? That is the piece where it's increasing. So this increases, and then it decreases slope. This would have positive slope, comes to 0, but then it still is increasing. But we need to eliminate it down to where also are these y values positive. That's anywhere above the x-axis. And so really, that cuts it down to being from here to here, and then from here, 1 to 9. Okay, so then the intervals would be -7 to -4. And then 1 to 9. And I'm going to do parentheses because we talked about how it's not really increasing there and it's not really positive there, but I think it'll take brackets as well. Number 2, given the graph of the function f below, determine all intervals on the open interval where f prime of x is just less than or equal to 0. So where is the slope negative? Where is slope negative? So here I'm going up. So these would all have positive slopes. Positive. I'm decreasing until I get to this minimum back here. I'm increasing, and then I would decrease. And that's all it wanted. It didn't want where f or the y's were positive or negative. So I would put from -3 to 3 and from 7 to 9. All right, number 3, given the graph of the function f below, determine all values of x on the open interval, -9 to 9, where f prime of x goes from negative to positive. Where does the slope go from negative to positive? So here we go up. So that's from positive slope to negative slope. So that's not what they want. Then it changes direction. So it goes from negative slope to positive slope. So they want here, we increase. Then we go from negative slope to positive slopes. That would be here. Then we go down, negative slope to positive slope. Negative to positive here. So there's going to be 3 different x values. What do you notice about the graph? What are those points that we would classify them as what we talked on the last lesson? These are relative minimums. So when you go from slope of a normal graph, where you go from slope that's going down to up, you've created minimums, little valleys. And so we've got x equals -2, 3, and 7. And number 4, given the graph, function f below, determine all values of x on the open interval -9 to 9, where slope is 0, but f prime does not change sign. Okay, so slope needs to be 0. We talked about if I drag this, slope is going to be 0 here, and here, and here, and here. Any dips or valleys or anywhere where it flattens out, but does not change sign. So this is going to go from positive slope to negative slope. That changes sign. This is negative slope, 0, negative slope. So this would be one of the points. And then we go positive slope and negative slope. And so I would want this point only, -2. It kind of reminds me of those slides at the fair, you know, when you have your, what are those, not gunny sacks, but you know what I'm talking about. I guess they're called a gunny sack that you slide down.